Our last topic in solutions is percent concentration. So we'll figure out what is meant by weight by volume as well as volume by volume. Okay, so percent concentration is just another way to think about the concentration of solutions. So we've talked about molarity, which is moles per liter. Concentration is the amount of solute dissolved in a given amount of solution. So we can look at this a couple different ways. We can look at this as a weight by volume percent, which you have possibly seen before as a percent weight by volume. And this is just taking the number of grams of solute dissolved in 100 milliliters of solution. Now, if the amount of solution is not given, 100 milliliters is assumed. Sometimes you'll be given a different volume, so just pay attention in your questions as to what you're given. So this is a percent calculation. You've done 1,000,000% calculations in your academic career thus far. This is no different. So here I want to know what part of the entire solution is solute. So I take the grams of solute divided by the volume of solution and I multiply this by 100. It is literally that simple. The only time this gets a little bit more complicated is if I'm given, say, the percent and have to work myself backwards. But in which case this is just an easy algebraic conversion for the most part. Let's practice. I promised you we'd be ending on an easy note. Check this out. We're going to calculate the percent weight by volume if 6.7 grams, that's my grams of solute, is dissolved in 100 with a decimal milliliters of water. That's my milliliters. Okay, so according to my percent weight by volume, again, percent weight by volume, my mass, 6.7 grams of solute divided by 100 with a decimal milliliters of solution. Okay, this is going to give me a decimal. I'm going to multiply it by 100 to make this a percent. I am going to report in the least number of sig figs given in the problem, which is 2. My answer is 6.7%. It's that easy. As nurses, you'll be using percent weight by volume calculations all the time. Maybe not calculations so much, but you should have a good understanding of what that means in case you have to mix anything yourself, although hopefully your pharmacists are doing all that for you. You guys have a lot on your plate already. But we see percent concentrations in all kinds of everyday substances like Listerine. There is a percent concentration of your active ingredient in your volume of liquid. One that I like to use as an example is a sore throat spray. So one of those sprays, I don't know if people actually use these anymore. I remember my granny, when I was a kid, she'd spray this and it would just burn and it was awful. I was shocked to find out what the active ingredient is. But looking at the back of this, this says, I'll make this larger in case you can't see it on your screen, 1.4% phenol is your active ingredient. So this is a weight by volume. It might be a volume by volume, depending on how the phenol is added in. But again, it's telling us that 1.4% of this solution is that active ingredient, phenol. So we see this on medications a decent amount. Our next type of percent concentration problem is going to be a volume, percent volume by volume. So this is where we're taking a liquid and we are adding that liquid solute into 100 milliliters of solution. So we're creating a solution, but this time instead of a solid or grams, we're using a liquid. Same calculation. We're going to take the volume of our solutes and the volume of our solution, times it by 100. If you're not given an amount for your solution, assume it to be 100 milliliters. Also notice your units are going to have to be the same. You can't have liters on the top and milliliters on the bottom. So convert whichever way you need to because a percent doesn't matter, but they have to be able to cancel out. None of our percent concentrations are going to have a unit as a result of this canceling out. Let's practice. Calculate the percent volume by volume of ethanol, that's the drinking kind of alcohol, if 0.50 milliliters of ethanol is dissolved in 100 milliliters of solution. So again, setting up our percent volume by volume, we always want to put the smaller amount on the top. Otherwise, it doesn't work. So 0.50 milliliters, and again, you should be told in the problem which one's the solute, which one's the solution, but always smaller amount on the top. Is dissolved in 100 with a decimal milliliters of solution. We're going to multiply that by 100. My units will cancel, which is why I don't report in units. I report in a percent. And once we multiply by 100, we get 0.50% volume by volume. I'm reporting to the same number of sig figs as the least in the problem. You may have noticed at this point that your percent, if you're dealing with 100, if you're dealing with 100 milliliters of solution, your percent volume by volume or weight by volume is equal to the solute amount. If you have 100 milliliters of solution, those should be equal. So you might be able to save yourself the setup of a problem if that situation arises. You just know that they're equal. We see percent volume by volume every time we think about the alcohol by volume or the ABV that we have in our beer or our wine. This is a percent volume by volume where you're looking at the amount of ethanol in a certain amount, your bottle of liquor, your bottle of beer, your certain amount of milliliters of solution. So it's literally a percent. And that's how we report the ethanol or the alcohol content. And so wine is typically a 10 to 13% volume ethanol per however many milliliters you're reporting it. Beer tends to be 3 to 5%, although all of these craft breweries are really pushing that range up higher. Anyway, it's been a pleasure. Hope you've learned a lot from chemistry. We'll see you next semester.